So the first one had an equation. So you can find your common denominator, multiply through your common denominator, and eliminate that denominator. Solve. Look for any domain restrictions first. Your domain restriction, you can't have a 0 in the denominator. Eliminate your denominator, solve it, then go back and make sure it checks. If it's one of your restricted ones, automatically it's not going to work. We're okay with this? Okay, so now, say on your test you have this. This is why you have to show me your work. I'll give you a point for getting the domain. Usually we do a point for the common denominator. We usually come down, we expect this, usually sometimes we give you a point here, we give you a point here, we give you a point for your answer. So this could be worth 5 points. So if somewhere along the line you missed something, like from here you got this, but you didn't get this, you still have at least 3 good points here. You're going to lose a point for this, but then if you found your answer correctly, you get a point there. So really these are a nightmare to grade. It takes forever to grade because I do have to follow every problem through. So we just kind of break it down and it makes it easier for us. We take away all our subjectivity there. So it's very objective when we grade. Everybody has the same, basically the same. Now I may look and combine 2 things. I may say, okay, you got this, and add them together like that on some and some not on the other, but they all work out in the end. And at any point, you can ask me, what you got wrong or what you didn't understand, what happened there. What I'll try to do is say you have, this is 5 points, I'll go like this, 5 out of 5. If you got 4, I'll say 4 out of 5. So you kind of know what the point system is. It makes it easier for you to check to see what you have too. I guess my board is off. So it hit something different. Yeah, I did a screenshot because my board is off. It's always on the side that it's off. I don't know why. Alright, so I'll try again. Okay, again you have another equation. Find me your domain restrictions. Give me your domain. I'm always looking for your domain. That's a given. Always give me domains. If any, with any restrictions. If it's all real numbers, then don't worry about it. But if there's any restrictions, I need your domain. Again, give me a common denominator, multiply through. Come down here, it's a quadratic, so you'll probably get an extra point in here. Then you'll get an extra point for saying reject. If that's the point you lose, maybe you lose 1 out of the 6 or 7 points that there is, because you didn't reject it. Generally, our tests are anywhere from 30 points to probably 50 the most. And the way we work it too is, by the time we check all the homeworks, that's another test group. So if you figure in one marking period you get like 30 homeworks that I check, that's a test grade. 35, 36 homework. That's a nice little test grade.
You just like cross out the wrong answers. Is that like the same as checking? You have to write reject.
Yeah, well you should say reject. If you cross it out, I'm okay with that, but you should say reject. You had to on your regions. You had to say reject. God bless you.
For number 2, aren't you supposed to like multiply the second thing by x minus 3?
Yes. Yes, which I did, because this was a 1. This was a 1, so I multiplied it by x minus 3. And this one had the x minus 3, I had to multiply by x minus 1, but because it is subtract, I have to distribute that. Did you reverse them?
No, I multiplied the last term by x minus 1 squared because there was 2 of them.
Okay, so don't always look at your denominators. Once you find you need this factor. This one already has one. Don't count it again. This one has it. So if you made a fraction like this, what's your common denominator? 10, not 20, right? So it's the same thing when you have binomial. And if it helps, Anne-Marie, write it on the top of everything. And then this way you can kind of reduce on each term. And if you did x minus 1 twice on all of them, it'll still come out to be the same answer.
I got -2 and -1. So
That means somewhere your sign got messed up. I'll take a look at yours after this is done, because even if you did 2x minus 1, it still should work. So at the end of this, remind me, I'll come over and take a look at it. Okay, isolate your radical. Here's your domain. Now be careful on your domain restrictions. This one, this argument says x has to be greater than 5. I'm allowed to have a 0. This argument says x has to be greater than -7. But if this is true, then this one won't work. So it has to be where they overlap. So your domain has to be from 5 to infinity. Okay. Isolate this. It doesn't matter to me which one you move over, the first one or the second one. Get them all to one side again. I found it easier to divide by a -12. See, if you're going to square these numbers, they're kind of high, which is fine if you do it. Just remember to distribute it. So I multiplied it, brought it down, solved it, go back and check it. So 9 minus 5 is 4, square root of 4 is 2. 9 plus 7 is 16, square root of 16 is 4, and it checks. That's all I need for a check. I mean, you can do it in your head, or put it in your calculator.
Oh wait, where did you get the 12 from? In the second line where it's 36 minus 12?
Because this will be, you got to multiply this out, remember?
Yeah, I remember that.
So this gives me 36. This gives me -6. This gives me -6. And then the last thing I do is take that out of there. So this here, there's my -12. Combine your middle terms. And that's the one you're going to end up isolating again, is your middle term. Move this over, get rid of the 7 and the x, move that over, combine that and move it over. Then isolate it again. Yes?
when you put x equals 9, why'd you put it in 1?
Oh, this is just a set notation. It's just a set notation. Don't use a soft bracket, because that's more of an interval or a coordinate. Set notation is, like, say I had 4 answers. I just put it in set notation brackets.
So like, do we always have to do it?
You didn't do that in algebra 2? Set notation?
Not for like one number.
That's fine. The x is equal to 9 is fine. It's fine. I just tend to, sometimes I guess I do, sometimes I don't. We're okay with this though? I mean, this would not lose you a point at all. Not at all. If this didn't work and you didn't say reject, then you lose 1 point. But this one has a bunch of things going, so this one's going to be worth a little bit more. Probably a good 8 points.
And then domain, why you put negative infinity?
This domain is for this guy.
Oh, okay.
Sorry. This domain is up here. This one goes to this. There's no restriction on the next one.
So like, how do you know that?
Well, this absolute value one, you can put any x you want in there. It doesn't mean that it's going to make it true. It just means these are the allowable x's you can try. Like, there's no fraction in there, so there's nothing, or there's no radical. There's nothing to stop you from trying that x. But it doesn't mean that's not my solution. This is my solution. This is my possible domains I could look at. You know, a good one to look at domains is the domain of all the planets. Right? Think of all the planets. That's my domain. Mercury, Venus, Earth, Mars, blah, 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 blah. And then I ask you a question and I say, which planet has the rings? So you look up to the planets and you say, Saturn, right? Saturn has rings? Uranus has rings too? Okay. Saturn and Uranus then. Okay, but what if I said to you, what planet does Superman come from? Is that in my set of 9 planets? From Krypton, right? From planet Krypton. But is that in my set of 9 planets? No. So therefore there's no solution. So it's out of your set of possible numbers. So out of my set of possible numbers, these are the answers I'm getting. Think of it kind of that way. All right, this one I've changed for you, right? I made it a less than. I had to do it on the computer because I didn't have my calculator. So you have two paths. You have the positive path. Your absolute value is isolated. Make sure it's all by itself. Then bring this out. I'll do it the quick way too. Bring this out for those of you that like two paths. The first one stays the same. The second one takes the negative of what's here. And then in inequality, the sign changes. So you always have to flip the sign. Resolve. Now remember, guys, what's the problem back there? So this one's saying this is going like this. This one's saying this is going like this. We want where they overlap. So for and statement, just drop down your endpoints. It's not equal, so it's a soft bracket. Now, you can also do this one the quick way, because it's an and statement. Your absolute value is isolated. Drop it down. This statement right here is the exact same as this one. It's just flipped around. So now, add 9. And divide everybody by 3. This is the nice one to do, the and statement. And then just write it in interval notation. There's your endpoint.
You can only do that when it's an and.
When it's an and. And you can only do this and when there's no variable on the right-hand side. If I put a 7x here, then you can't do this, because if I put a 7x, how would I solve for x here? This would say 7x plus 9. How would I solve for this x? I wouldn't be able to. So if there's a variable on this side, you have to separate it. If there's no variable, then that works real nicely. I changed this, so this x doesn't really belong here.
First, do we have to for the domain, do we have to put the, like, negative value to variable?
Yeah.
Or a point? Okay.
Yes. If you have to eliminate one variable, one number, you have to do it. Yeah. Questions? No? Okay. Anne Marie asked, when we have a domain restriction, do I have to do this out? Yes. This is the most important thing. Right here. I want my allowable domain. That's not my solution, that's my allowable domain. So this has a rational expression on this side. It's a rational inequality. So you're going to have to bring this one over, make this one term. Find the common denominator, make it one term. Once you find the one term, then you're going to do zeros of the numerator, zeros of the denominator. Zeros of the denominator is your domain restriction zeros. Do I need to see it again? No. You already have, as long as you did your domain restriction, you have your zeros of the denominator.
Shouldn't the domain have a hard bracket because it's equal to?
So this is equal to 1, but am I allowed to use 1? That's the one I want to remove. So technically I'm looking at this. Get 1 out of here. So I can use all of these. I can come from negative infinity. I can stop at 1 but not use 1. Then I'm going to jump over it and keep on going. So technically I use 0.9999999. I use 1.0000001, but I can't use 1. That's the concept of the soft bracket. The zeros of the numerator, zeros of the denominator, and make sure you test. You should put this in you're going to have to put it in, you don't have to, I mean you can plug values in and work them all out. But easiest way, plug this in your calculator into your y1, make sure it's all on one side first. Plug it in your calc on y1 and see where your value of your graph is positive or negative. And in this case, you want the positives and you want the zeros. It's also a good thing if you put this in your y1 to put this in your y2. The one you ended up with. The 2, I did 2 minus 1. You want to combine all your terms. You needed to like clean up everything
So
by your like terms.
the domain restriction is 1 point, but the one on the bottom is out of like 2. So it's like negative infinity to negative 1 with the hard bracket. You need to have
No, this one. This is your solution to this. This is your solution. I probably should have maybe done them in different colors. This is your domain, the allowable domain. Remember, when you do an equation, what number of x can this possibly be? Not that I'm solving it, but it could be any number that I want it to be, right? Any number that makes this statement true. So my domain is all real numbers. Put any x in there and see if it's true. So I stick a 1 in there. Is it 1 plus 2 equal to 9? So that's not my solution. I put a 7 in there. Is it 7 plus 2 equal to 9? So that's good. So I know one of my answers, I know my answer is 7. This is my solution. This is my allowable domain that I'm allowed to look through. Now, if I took this out and I said, your domain is all irrational numbers. All irrational numbers. That's the domain you're allowed to look at. Does this have a solution? So my domain is all the allowable things that I can look at. My solution is my answer. Okay, it kind of makes sense a little bit? That always is, you're not the only one, that always is confusing. Kids confuse the domain with the solution. The domain is anything I'm allowed to look at. You know, sometimes they say, okay, case in point, I have 3 odd numbers, 3 consecutive odd numbers, and they add up to, I'm just going to make this up so it probably doesn't work. They add up to 31. Twice the first number plus the second number is 10 more than the third number. What kind of answer do I expect to get? Of what type of number would it be? At 3 consecutive integers. So could my answer be 1.5?
No.
And my answer has to be an integer. So when I say consecutive integers, you're looking at every integer possible. Does it mean that's your answer? No, my answer could be -3, -1, +1. It could be 3 consecutive odd integers. It could be 1, 3, 5. That's my answer to that problem. So my domain is all the allowable things that I'm allowed to look at. That is a tough concept to get. Usually Algebra 2 Honors does a little bit more with that, but I'm not sure how Common Core switched it around. You're my first Common Core Algebra 2 group that's coming through. So if there's something that I'm doing that you say, wait, we never saw this before, let me know. I'm not really sure what's changed for you guys. I know whatever they've changed, they moved earlier to geometry, usually. But some things could have changed. So just tell me. So I don't have a clue what you're doing. Okay. Another rational expression over here. This is a rational inequality. I'm dealing with an expression when I look at this side only. So this part says, get me a common denominator. Convert your numerator, make it look pretty. My domain restriction is my denominator. Right now, that will never cancel out on you right now, because this gives me an asymptote. This gives me a value of x that I cannot use. When I graph this guy, if you put this in your y1 and get used to graphing this, you're going to see I have a value of x that I cannot use. And it stops my graph from being continuous. So let's just graph this. Alright, let's see what this looks like. Well, the 2 is in there. Just ignore the line that comes up. Just ignore this line over here. So you see what this is doing? It says, whoops, this is going down, 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 down. You took a break here. There was something that caused me to break. Something right over here, right barely into the negatives. And then it started up again and went like this. So where was that break? -1, because I'm not allowed to use -1. And I look at my table, my -1 says error. You can't use -1, because -1 will give me a domain of 0. Am I ever allowed to have a domain of 0? No. That's why graphing these is so important when you're first getting used to doing your domains. You can see it right away. When we did that absolute value and I said my domain is infinity, I can use any number that I want to. If you graph it and you just scroll along your table, you will never see the word error. I can put any number I want in there. It doesn't mean that's my solution to what I'm looking for, but I'm allowed to use any number. And a good thing to do here is, in the second one, put this guy. And then you know that you did everything right. Because if it's not the same graph, you didn't change your graph, you just kind of made it look a little different. If it's not the same graph, then something went wrong along your way. And that's the time you say, before I do anything else, let me see what I did wrong. It's a good way to check. If I graph this, there's my first one. There's my second one right on top of it, because if I look at my table is exactly the same. If I did something wrong, say I forgot the negative in here. Just say for some odd reason I forgot my negative. And I graph it. Here's my first one. Whoops, I have a different graph. So it says to me, somewhere along the line, something went wrong. So when I went here, and I said x minus 2x, and I put a positive x, that should have been a negative x. So it'll kind of tell you something's not right. Even though these look strange, and you'll get used to seeing those. We do a lot with asymptotes in here.
I'm confused with it's a lesson statement, but the solution is like
Right, because it's a rational term. It's rational, so it doesn't conform to the same as the other ones. That's why these you have to do out. You have to put in your calculator. It's not like a quadratic. A quadratic, we can draw the quadratic. We can see where it's less than. We can see where it's greater than. That conforms most of the time. These do not conform because what happens is they're not continuous. Something's causing them to stop. Yeah, otherwise, it would have gone and then maybe come back up again or keep on going. But something's causing these to break. So they do not conform to what quadratics conform to. And you're right, this is the confusing one. Remember when we were doing this, I said this one's the hard one. Because it's not what you would expect it to be. I can't do this without my calculator, without putting it in my calculator. I mean, I know where my domain restriction is. I can guess. I can say, okay, here's my domain restriction. It's probably going to go like this. It's probably going to go like this because that's what they all do. Unless it's a negative, and then it's going to go the opposite way. It's going to go down here, and it's going to go over here. So you can kind of see where it's going, but to put it in, I would put it in my calculator. These, all I wanted you to do was find your domains for these. No solutions. You're going to have a section like this tomorrow on the test too, where you have to find your domains. I want the allowable domain, the restricted domain we call it. It's restricted because not every piece of your real numbers is in there. So all I care about in this one is my radical. Take what's in the radical. We only have 3 things you have to worry about. A denominator cannot be 0. Under a radical cannot be negative. And a radical under a fraction cannot be negative and cannot be 0. So put your radical greater than or equal to 0. This is one of the problems that I know kids have a hard time with because it's not like setting it to 0 like we do before. This actually builds your domain. The fraction one, when you set it equal to 0, tells you the ones that you cannot use, and then you take it out of your real numbers. This one actually builds your domain. So we say, okay, watch the sign. When you divide by a negative, you're going to flip it. So if it helps you, put it on the number line first. Test the 0. Can I put a 0 in here? Can I put a 7 in here? No, because 7 will give me a negative under my radical. Can't have that. I don't care about the rest of it. I'm not solving it. I'm just saying what numbers can you look at to use. This guy too has a radical, but it has a quadratic. So now when you do this, you have a quadratic inequality. A quadratic inequality works nicer than your rational ones because what happens is, and you can put this in your calculator as well, and this is where your x-axis goes, these are where your roots are, your zeros are. So it kind of says, okay, I drop down here, there's my negatives, there's my positives. This one follows nicely because it's a quadratic. And you can absolutely graph this guy instead if you're not comfortable with that. Graph it, put this in, x squared minus 7x, don't even factor it. Just put it in so that you could see it. Okay, when you graph this, do you see it drop down here? There's your negatives. So now if I'm testing, I could find my 0, I could find my 7 here. It's in my table. My 0 is 0 and my 7 says 0 here. If I look to the left, there's my y's, they're positive. If I look in between, there's my y's, they're negative. If I look to the right of 7, there's my y's, they're positive. So you can use your graph as well. The quadratic is nice because you pretty much can just superimpose that right onto your line. And there's your answer. I want the ones that are positive, I want these guys, I want these guys. I have a hard bracket because I have an equal sign for my inequality. If this went like this, then what would change for my domain? It would be a soft bracket. That's the only thing that would change. It would be a soft bracket. This guy, this is a denominator. What can my denominator not be? 0. So set it equal to 0 and find me the two numbers that it cannot be. It's not an inequality. It's two little numbers that it cannot work in. So take this out of your number line. Easiest way, -3, -2. So read left to right. Come over here, stop at the -3. Jump over it. Start again at -3 to -2. Jump over it. Go -2 to infinity. If you say to jump over it, it doesn't, you won't miss the middle part. Like you're on a continuous number line. I'm coming up to -3. I can't use -3, so jump over it. But I can use right to the right of it till I hit right to the left of -2, then jump over it. Makes it easier. Here we have another situation. We have a radical in the denominator. A radical in the denominator cannot be negative, cannot be 0. So we set this greater than 0, no equal to, but it's a quadratic. It's a quadratic. A quadratic goes like this. It's opening up. So where do I want my positives? Here and here, where my value of y is positive. Yes. So from -infinity to -10, notice we have a soft bracket. Then this one, just a simple, can have 0 in your denominator. Get it out of there. Take the 0 out, so jump over it. -infinity, stop there, jump over it, and restart. All I want for these guys is domain. So you're going to have one little section tomorrow with a domain on it.